Hello, good morning students. So today let us see the topic of scales. So what is a scale and what are the types of the scales and how the scales are useful in the general engineering purpose. So let us go for the topic. So now let us see the introduction. So the term scale is defined as the ratio of the length of a line in the drawing to the actual length of the edge of the object. This ratio is also called as representative factor. So what is representative factor? So representative factor is nothing but, see here, the length of the line in the drawing. So what you have drawn in the sheet, the length of the line in the drawing. So what is the length of the object? Suppose the length of an object is 1 kilometer and you have represented it on the drawing by 10 centimeters. That is nothing but you are representing 10 centimeters line as 1 kilometer in the drawing. That is nothing but the representative factor. So it can also be represented as representative factor, or that is RF. So the RF is nothing but the full form representative factor. So the length of a line in the drawing by actual length of the edge of the object. So let us see what are the different types of scales. The scales are divided into, one is full size scale, second one is reducing scale, and third one is enlarging scale. So what are these three types? Full size scale, that is nothing but 1:1. Reducing size means, suppose if you have a large picture, then you have to reduce it into your drawing sheet. Enlarging scale is nothing but when you have a very small and minute object, then it is going to be enlarged in such a way that it can be seen very clearly, right? So let us see what is full size scale. So it is a customary to represent objects to their actual or full size in the drawing if their sizes permit. This gives an idea about the size of an object without leaving any for imagination. So a drawing is said to be prepared to full size scale if the actual sizes of the edge of the object are used in its presentation. Suppose if a 10 centimeter square is there, you can represent it in a paper. So if at all a 50 centimeters square is there, you cannot represent it on a paper, so that you use the scale, that is reducing scale. So like that, depending upon the geometrical shape and the geometrical lengths of an object, you are going to select the full size scale or reducing scale or enlarging scale. So now let us see what is a reducing scale. It is not always possible or convenient to prepare drawing of an object to its full size. For instance, drawing a very big objects such as building, large machine parts, town planning, etc. cannot be prepared to their actual sizes. In such cases, it is necessary to prepare a drawing to a reduced size. In some proportions, it is said to be prepared in a reducing scale. Okay, then next, coming to the point of another one is enlarging scale. So enlarging scale, the drawing of very small objects like the parts, precision instruments such as watches, electronic devices, etc. cannot be prepared even into the full size because it is in the very small, minute cases, as they would be too small to draw and read as well. In such cases, they are represented by enlarging scale. So here you can see a scale factor or representation factor. The complete designation of a scale consists of a word scale is followed by the indication of its value. So that is, it is nothing but full scale. That is the scale 1:1 for full scale, 1:x for reducing scale, how much you are going to redress is going to represented by x value, and scale x is equal to 1 for enlarging scale. So how much quantity or how much geometrical extension that you are going to do, it is represented by x, that is equal to 1 centimeter or 1 millimeter, whatever it is. So here the next slide, the table shows you, gives the scale standards factors that are available in the use. For example, maps, shipbuilding drawings, aeroplane drawing, watches, design, machinery parts are the some of the examples for the reducing scales as well as the enlarging scales. For full size scale, it is not necessary when the length of an object is fit for the available paper. Okay. Next, this is the sizing factor or scaling factor. The standard size, this is full size scale is 1:1. So reducing scale 1:2 or 1:5 or 1:10. So like this, these are the different ratios for the reducing scales. So 1:10,000, suppose 1:1000 is there, that you are going to use for the maps, geographical maps. So if you see the Google Maps, when you go into it, you can see the scaling factor at the left bottom corner of the your screens. So that is that one. And next, coming to the point of enlarging scale, it is a ratio of 50:1, 20:1 and 10:1, 5:1 and 2:1. These are the different factors that you are going to consider with the recommended scaling factors. So right, so then afterwards we can see type of the scales. So the previous topics are nothing but the differentiation. Here the type of scales can be categorized for the engineering drafting practice. One is plane scale, second one is diagonal scale, third one comparative scales, fourth one isometric scale, fifth one vernier scales, and last one is the scale of Kurtz. So plane scales, if an available length is there, then it is easily drafted on the paper or drawing sheet. And diagonal scales are especially used to define or to produce a length with two places of numerical values after the decimal. Suppose if you take an example of plane scale, 5.6 centimeters. So 5.6 is possible in the plane scale. Suppose if 5.66 is there, so it 5.66 centimeters is not possible in the plane scale. So that we employ the diagonal scales, right? So the simple logic is, when you use the diagonal scale means when the two numericals are there after the decimal, then you have to go for the diagonal scales. And another one for using of two numerical values after the decimal is vernier scales. But today I am going to explain about the plane scales and as well as the diagonal scales. So here, scale on the drawing. So what should be represented after the drawing? So after the drawing, these are the instructions. 1, 2, 3 are there. One scaling factor, that is nothing but representative factor. The units and subunits to be represented, right? And the maximum length of the scale or the scale length of the scale to be measured and shown on the drawing. So right. So we'll go for the next one. So here you see the metric units. So the relation between the various units in SI system are given below. So the first one is the minimum length that we can find is 1 mm. All of you know, it is 1 mm, which is on the normal scale. So now 10 millimeters is equal to 1 centimeter, is everybody know. 10 centimeters is equal to 1 decimeter. So these are the different units that you are going to get. So please kindly to remember these things. 10 centimeters is equal to 1 decimeter and 10 decimeter is equal to 1 meter. This is also known for you. And 10 meters is known as 1 decameter. 1 decameter. So here you can see 1 decimeter, small d and m, it is represented by. Decimeter is represented by small dm and decameter is represented by capital D and m. So 10 decameters, DAM or DAM, you can call it as DAM or capital DM. So 10 decameters is called 1 hectometer. 1 hectometer. So 10 hectometers is called as 1 kilometer. How many meters are there for 1 kilometer? So 1 kilometer is going to represent by 1000 meters. So this is the SI units that you have to remember very carefully. So because all the problems will come in this manner, such that you have to understand what is the unit and how much divisions that you have to make it, right? So let us see, this is a plane scale. So what is a plane scale? So plane scale is a line suitably divided into equal parts, primary divisions, is called as a plane scale. Generally, the first part of the subdivided into a smaller parts, that is secondary divisions. Thus, a plane scale is used to represent either two units or a unit and its functions such as kilometers and hectometers, meters and decimeters. So simply you have to remember that the first division is to be set as 0 and the right side of the 0 will be units and the left side of the units will be subunits of that one. So here if you see meter and decimeter, so meter is a unit and decimeter is a subunit. And if you see here, kilometer is a unit and hectometer is a subunit. So 1/10 of the kilometer is nothing but hectometer, right? So let us, if you go into the problem, then you will be easily understood what is subdivision and what is division. So let us construct a small scale, that is construct a scale of 1:8 to show decimeters and centimeters. So what is decimeter and what is centimeter? So you have to remember, right? And read up to 1 meter. So here the maximum length of a line is given. So to be shown on the scale is given. Show the length of 7.6 decimeters on it, right? So here, first of all, what you have to do, the procedure to construct a scale is, first of all, you have to find out the representative factor. So what is the representative factor? It is not here. Here the scale is given is 1:8. So this 1:8 is nothing but the representative factor, that is nothing but 1/8. So here, obtain the length of the scale. To obtain the length of the scale, first of all, you have to find out the scaling factor. So scaling factor into the length. What is the scaling factor here? RF is nothing but the scaling factor 1/8. So this 1:8 is converted to fractional form, that is 1:8, that is 1/8 into 1 meter. So here you can see the length of the line to be shown on the drawing is 1 meter. So 1 meter is going to be represented by 1000 mm, that is equal to 125 mm, that is 1/8 into 1000 mm gets 125. So now this 125 mm is called as the length of the scale. So you are going to represent 125 mm line on your drawing to show 1 meter length on your paper, right? So here draw a 125 mm long line. Okay, divide it into 10 equal parts, primary divisions geometrically. Each part is representing 1 decimeter. So here you can see the picture here. So first of all, you draw from this point to this point, it is 125 mm, and divide it into 10 equal parts by line division method. So 1, 2, 3, 4, 5, 6, 7, 8, 9 and this one is 10. So as already previously told you that the first division, this one, this is the first division. The first division should mark as 0, and after that 0, 1, 2, 3, 4, 5, 6 up to 9. And the left hand side division is going to make 10 more divisions. Why? Because the decimeter and this is centimeter. Decimeter is nothing but 10 centimeters. So here 0 to 1 represents 10 centimeters, and here this particular part also represents 10 centimeters, and this left hand side to 0 to left hand side is divided into 10 equal parts such that each part is going to represent 1 centimeter of the length, right? Next, Divide the first division into 10 equal parts, that is secondary division, each part representing 1 centimeter. So it is clear. Mark the secondary division points from the right to left. So right to left. So here this is 1, this is 2, this is 3, this is 4, right, 5 and so on up to 10. Next, write the units at the bottom of the scale and their representative factor and the scaling factor. So you can see the scaling factor, that is nothing but representative factor of 1 by 8, what we have done here. So this is representative factor and these are the units and these are the subunits. So suppose if units and subunits are not specified in this one, then ultimately you cannot have the full marks in the scales. So now what is to be found? So here the 7.6 decimeters should be found on the scale. 7.6 decimeters, 7 decimeters and 6 centimeters. 0.6 is nothing but 0.6 decimeters is nothing but 0.6 into 10 is nothing but 6 centimeters. Okay. So 7 decimeters. So how you will find out 7 decimeters? So here from 0 to 1 it is 1 decimeter, 1 to 2, 2, 3, 4, 5, 6, 7. So now I draw a line here, 7th decimeter. Okay. And next, so from here to here, this point, we are 7 decimeters. And I want 0.6 decimeters. 0.6 decimeters is nothing but 6 centimeters. Where in the subdivision, one division represents the 1 centimeter. So I count 1, 2, 3, 4, 5 and 6. So now from the 6th subdivision part I will draw a line and I have a dimension line on that. It represents the 7.6 decimeters. So this is how to produce the scale in a normal manner, right? So let us see, mark the 7.6 decimeters, selecting 7 in the primary scale and 6 in the secondary division, right? So next we'll go for another problem. So construct a scale of feet and inches. So feet, you know all of you feet is nothing but 12 inches and this is a subdivision. This is division and this is subdivision. In the measure up to 7 feet. So this is the longest length or the maximum length. To a scale of 3 inches is to 3.9 inches. So here the scale is given in the form of ratio. You have to convert it in the form of representative factor, that is 3 by 3.9. Mark on it a length of 4.7 inches. 4 feet 7 inches. So how we have to do, just we will go through that one. So first of all, obtain the scaling factor, that is 3 inches by 3.9, that is equal to 3 feet is nothing but 36 inches. So 3 into 12 inches, 36, and 3.9, 36 plus 9 is nothing but 45. When you cancel it, you will get 4 by 5. So the representation factor is nothing but 4 by 5. Then next, calculate the length of the scale, LOS. Okay, now LOS is nothing but representative factor into the maximum length. Where is the maximum length? Here it is 7 feet. So here the feet is converted to inches once again. So here 7 into 12, that is representation factor into the maximum length of the scale. That is nothing but 5 feet 6 inches. So here this 5 feet 6 inches is once again converted to centimeters, because in inches scale you are a little bit confused. So simply for calculating inches to centimeters, that is nothing but 5.6 into 2.54, because 1 inch is equal to 2.54 centimeters. So that you will get the answer, that is draw a line of 5.6 inches long and divide it into 7 equal parts. Why 7 equal parts? Because the total length of the scale is representing 7 feet. That is why I am making 7 equal parts. So every individual scales problem will have different divisions, not 10 divisions or not 7 divisions or not 6 divisions. Depending upon the problem, depending upon the maximum length to be found, that is representing on the scale. That is why here 7 feet is the maximum distance, so that I am making it 7 equal parts. Each part represents 1 feet, right? 1 foot, sorry. So here you can see the diagram. So this is the total length of the scale. Representation factor is 1 by 15. So here it is wrongly printed. It is 4 by 5, right? Then here division, this is 1, 2, 3, 4, 5, 6, 7. So already I have said you that first division to be noted as 0, and right side of the 0 you increase the numbering up to 6, and left side of the division 0 is represented with the subunits. So here feet is a unit and inches is the subunit. So how many inches are there for 1/4? So 12 inches. So in the previous case we have seen that decimeter and centimeter. So for 1 decimeter we have 10 centimeters, but 1/4 we have 12 inches. So this particular length is going to divide it into 12 equal parts. So by line division method, right? Okay. So next, now 0 mark after first division and continue with 1, 2, 3 on the right side of the scale, and divide the first division into 12 equal parts in the secondary case. Each parts represent 1 inch. Okay. Then next mark the secondary divisions from right to left. So from this point to left hand side, right to left. Okay. Next, write the units at the bottom of the scale in their representation position. This is scaling factor, this is unit, and this is subunit. Is once again the same. And mark the 4.7, that is 4 feet 7 inches, choosing 4 in the primary division and 7 in the secondary division. So here let us see on the scale. So this is 0 and this is 1/4, this is 2/4, this is 3 feet, then this is 4 feet. So now I will draw a line here. Okay, then next I want 7 inches. 4 feet is over, and next I want to have 7 inches. So 7 inches I will select in the left hand side of 0, that is 1, 2, 3, 4, 5, this is 6 midpoint, and this is 7. On the 7th equal part I will draw another line such that I will draw a dimension line from 4 to this 7th equal part on the subdivision that represents the 4 feet 7 inches what we have to be shown on the scale. So here we can show, suppose if you want 5.6, so here this is 5. If you draw a line here, it will be 5 and 6. So if you draw a line here and you draw a dimension line, this will become 5. So for each and every one single problem can show many number of 1.2, 2.5, 3.8, anything you can represent it on the single scale. So next let us go for another problem. So that is a rectangular plot of 100 square kilometers. This is in terms of area. Square kilometers is represented in a certain map by a similar rectangular area of 4 square centimeters. So 100 square kilometers is represented by 4 square centimeters. Draw a scale showing kilometers and mark a distance of 43 kilometers on it. So here it is an area. So first of all obtain a scaling factor. Calculate the length of the scale to be represented, say 50 kilometers. Okay, so 50 kilometers divided by 5 into 10 to the power of 5, that is 100 mm. So this is the representative factor, length of the scale. Okay, then next you see here, this is the scaling. Now divide this one into 5 equal parts. So 1, 0 to 1, 2, 3, 4, 5. The first division is marked as 0. First division is marked as 0. And next 10. This is 10 kilometers. And this is 20 kilometers. This is 30 kilometers. And this is 40 kilometers. And left hand side should 0 is 10 kilometers. Why I have divided into 50? Because I want to show you a 43 kilometers on it, so that I made it for 50. Okay, then next here I have shown you kilometers, and here it is also it is kilometers. This is 10 kilometers, 20 kilometers, but here each line represents, each subdivision represents 1 kilometer in this one. Okay, scaling factor is 1 by 5 into 10 to the power of 5. Well, this 10 to the power of 5 is nothing but kilometers is going to be converted into mm, that. Okay, this mark 0 in the same procedure of steps are there. So everything is there. So now mark a distance of 43 kilometers on it. So now representing this scale. This is 40, draw a line here, and 3 kilometers. So see here, this is the first division, second division, and third division. So I will draw a line through third division such that we will have a distance of 43 kilometers on the scale. So this is how to represent on a scale. So here the most important point you have to remember is you have to calculate the representative factor, that is the main. And next, length of the scale, LOS. LOS formula is what? Representation factor is multiplied by maximum length of the picture shown. Okay, maximum length of the shown length. Let us see, go for another one is diagonal scales. Okay, so here diagonal scales are nothing but if a fractional portion in a secondary division is needed which is too small to be subdivided, diagonal scales may be used with easy. Hence diagonal scales are used to measure 3 consecutive units such as kilometers, hectometers as well as decameters. And another one, meters, decimeters and centimeters. Decimeters, centimeters and millimeters. So in the previous case of plane scale only we are subjected to 1, that is units and subunits, but here units, subunits and sub of subunits. So like this we can represent 3 different units in a single scale, right? So now let us see what is the principle of the diagonal scale. So first draw a line AB, let it represent as 1 unit. So 1 unit of that one in the secondary division. So first of all draw a line AB. First draw a line AB with any distance. Then next draw a perpendicular line to AB from one end, that is AD. Okay, right. Through line A draw a line perpendicular to AB. Next, starting from A, mark points 1, 2, 3 up to D, which are at equidistances. So whatever you take, so what is the distance between A and 1? Your wish. But 1 and 2 should be equal to A1. And 2 and 3 should also be equal to A1 and 1, 2. So like that. So each and every equal part should be equal up to D. Right. Complete the rectangle ABCD by drawing the diagonal. So right. So parallel to AB you draw from D and you complete this rectangle and draw a diagonal AC. And afterwards, through 1, 2, 3 on the AB AD line, draw parallel lines to AB such that it meets the diagonal AC. Draw the parallel lines to AB such that the parallel lines meets AC diagonal and represent it as 1 dash, 2 dash, 3 dash up to 7 dash. Okay, considering similar triangle A1 1 dash, this is A1 1 dash, and ADC, so this is ADC. So see here, this particular part, this rectangle is divided into 10 equal parts, right? So A1 1 dash is 1/10 of ADC. Once again I am saying A1 1 dash is 1/10, 1 by 10 into ADC. So here this is clearly seen. Okay. So here thus A1 1 dash is equal to A1 by AD into DC, that is equal to 1/10 of AB, as DC is equal to AB. Similarly it is proved that 2 dash consequently. Like that you are going to define the diagonal scale. So now let us construct it. Now let us see another problem, that is construct a diagonal scale of SF, that is scaling factor, that is 1 by 2.5 into 10 to the power of 6 to read up to a single kilometer, that is the maximum distance to be calculate on a scale. Single kilometers means nothing but 1 kilometer, and long enough to measure 400 kilometers. So this is the maximum distance to be shown on the scale, that is long length of line is 400. So mark a length of 254 kilometers on it. So you have to show the 250 kilometers on the scale. Right. So here let us see constructional procedures here. Let us go for the previous slide. Sorry. So here, first of all, you obtain the total length of the scale. So total length of the scale, how much? That is representation factor into the maximum distance. So that is representation factor is nothing but 1 by 2.5 into 10 to the power of 6. That is 1 by 2.5 into 10 to the power of 6 into, this is the maximum distance. So that is 400 kilometers. That is 400 into 10 to the power of 6. That is converted into mm. That is equal to 160 mm. That is length of the scale is 160 mm. So you have to draw a line of 160 mm long line and divide it into 4 equal parts to represent 100 kilometers each. So here, see, this 160 millimeters length of a line is divided here. Okay, so 160 mm line. So 160 means 4 divisions. So how many each division carries? 40 kilometers. 100. So 100 kilometers, 100 kilometers, 100 kilometers and 100. Total, it is representing 40. So each division 40 millimeters, 4 centimeters, 4 centimeters, 4 and 4. Right. So the first division is to be taken as 0. As usually 100, 200, 300 and left side to the 0 is 100 kilometers. So here divide this 100 kilometers left side single portion is to 10 equal parts once again. So divide the first part 10 equal parts to represent 10 kilometers. So here each division represents 10 kilometers. Each represents 10 kilometers. Right, okay. Join D with the division point 9 to AO. Okay, to AO, forming the first diagonal line. So I will show you clearly. You please see clearly. So here I have divided. This is 1, 2, 3, 4, 5, 6, 7, 8 and this is the 9th part. So this 9th point is going to be joined to the point D here, such that this 9th point forms a diagonal to this particular rectangle. So here if you take this point, this will act as a rectangle here. So this will become the diagonal for the last column. And next, draw the diagonal line parallel to this 9 and D from point 8. This is point 8. So draw parallel lines like this from down to bottom. 7 diagonal line, 6 diagonal line. Like this you go up to 0. From 0 to just draw a parallel line to this 9 and D from 0 to end point. So now how to represent the kilometers such as 254 kilometers. So now I divide this 254 kilometers into 200 plus 50 plus 4, right? 200 is one block, 50 is another block and 4 is another block. So first I will take the 200. So here this is 100 and this is another 100. This is 200, right? So first I will take the 200 line here. Okay, the next 50, the second subdivision. So 50, this is 10, 20, 30, 40 and 50. So this is 50 kilometers. Okay, after 50, what is the third one? That is 4 kilometers. So I will go to the 4th point. This is 1, 2, 3 and this is 4. Nothing but here this 100 kilometers is divided into 10, 10, 10 kilometers and this line is going to divide 1 kilometer. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 kilometers. Right? So here these are 100 kilometers. This is 100 kilometers range and left hand side to this one is 10 kilometers subdivision and here in the vertical position these are kilometers. So here you can see kilometers and these are 10 kilometers and these are 100 kilometers. So now this is 200 and this is 50 and this point represents 4. That is nothing but if you draw a parallel line to the AD not to this line, okay, AD ki parallel ga మీరు draw చేసినప్పుడు then you will get a length of 254 kilometers on the scale. This is how you are going to represent the distance on the diagonal scale. Okay, then next we will go for another problem, that is construct a scale to be used with the map. The scale which is 1 centimeter is equal to 500 meters. So this is nothing but the representative factor. 1 by 500 meters, this meters is going to be converted into centimeters into 10 into 100, sorry. So that will give the representation factor. The maximum length to be read is 5 kilometers and mark on scale is a distance of 3.85 kilometers. So let us see what is the procedure. So procedure. Obtain a length of a scale. So you know the definition and the formula for length of a scale. LOS is equal to RF into the maximum distance. RF is nothing but 1 centimeter divided by 500 meters into 5 kilometers, that gives you 100 meters. So how you will calculate? 1 centimeter divided by 500, this meter is going to be converted once again into centimeter. So this meter is nothing but 10 to the power of 3. Okay, and here kilometers is divided into meters, once again centimeters, that is 10 to the power of 5. So here 10 to the power of 3 is there and 10 to the power of 5 is there, it gets cancelled. Only 2 will be there, 10 to the power of 2, that is nothing but 100. Okay, 5 and 5 also gets cancelled. You do calculation separately on your page. Okay, next draw a line of AB that is 100 mm long and divide it into 5 equal parts. Why 5 equal parts? Because we have 5 kilometers to be shown on the scale. So representing 1 kilometer each. So see here. So this is a drawing. So this is equal to the length of 100 millimeters. Now I divide this 100 millimeters into 5 equal parts such that one division is 2 centimeters. Okay, one division is 2 centimeters. The first division is taken as 0, 1, 2, 3, 4 and the last one is 5. Okay, once again I have to divide the left hand side hectometers, because this is units, this is subunits and this is sub of subunits, that is kilometers. 1 by 10th of a kilometer is nothing but hectometer and 1 by 10th of a hectometer is nothing but decameter. So now this 3.85 is going to be divided into 3 kilometers, 8 hectometers and 5 decimeters. It is clear? 3 kilometers, 8 hectometers, 5 decimeters, sorry, decameters. So like that you have to share it. So once again the procedure and of everything is same. Draw 10 equidistance parallel lines completely. Join D with the last division point 9 to AD. Okay, so this is the 9th point. Okay, and you have to join this 9th point to the last point D such that you will get a diagonal. Okay, and draw the parallel lines from the similar points 8 to 8, 7, 6, 5, 4, 3, 2, 1, 0. Like that, draw the parallel lines to 9 and AO. Okay, and divide this AD line into 10 equal parts. Okay, you complete all these drawings. Okay, and this 1, 2, 3, 4 and all these things. After that, you have to indicate the points, that is through remaining 7, 6 and 8 draw the lines parallel to D9. Then next mark 254 kilometers, 254 kilometers as shown. So how to mark 250, sorry, it's 3.85. okay, so now 3.85 means 3 kilometers. So now this is 0 to 1, 1 to 2, 2 to 3. This is 3 kilometers. Now I draw a line here, extension, and next 8 hectometers. So now I found out 1, 2, 3, 4, 5, 6, 7 and this is 8. So where is the subject? This is 5 kilometers. Okay, so 5 decameters. So now this is 1, 2, 3, 4 and 5. So now this 5, I will draw a parallel line to AD such that you will find the distance of 3.85 kilometers. So like this, so be careful while drawing the diagonal lines from ninth point to D point, and you draw the parallel lines only with the help of a drafter. Otherwise, you will get a wrong answer, and you may lose your marks, especially in case of drawing. Okay, so you will have a procedural steps, and one more thing you have to remember is you have to draw the dark line only up to this particular point, and other than the construction should be very light. Okay, so in case of plain scales or diagonal scales, the procedure is, the first thing you have to find out representation factor. So representation factor is in the form of factorial form. Whether it is given in the ratio also 1:5, then representative factor is 1/5. So to find out the length of the scale, the formula is representation factor or scaling factor into the maximum distance. Okay. So if you find out the length of the scale, half of the part is over. Then simply whatever the length of the scale is there, that simply you draw a line and divide it into equal parts, that to be mentioned how much. Suppose 10 kilometers, 10 divisions. Suppose 5 kilometers, 5 divisions. Suppose 20 feet, so you take how much? 20 divisions. So whatever it is, easy. So you would make it division with on your respect, and you have to mention units, subunits, and sub of subunits in case of diagonal scales, and this is mandatory. And below the diagram you have to mention the representation factor of the scale, such that you will get out of marks in the drawing. Okay, so thank you very much by watching me the video. So subscribe my channel with the given link. If you like it, you share it to others for the benefit of your friends. Thank you very much.